Hi there. We all want our code to be as clean and short as possible, right? Well, this tip is about giving the template part of your single file component a little shave and trim away the unnecessary stuff. Now, I'm Simon Wilmot. I'm a front-end developer from Belgium and a core member of the RQI team. Now let's see how we can do this and how we can use this step. So I got this small project as a demo, and it just shows an avatar. That avatar comes from a forged avatar that I created in my project. And well, the thing that we're going to look at is, of course, the template part here. And for example, we have a child component, the avatar image, which is from RQI Vue, and we're passing in two props in there, source prop and alt props, and those come from props that we use in this component that we have defined here at line 15. Now, the first thing that we can do, as you can see, it's a pretty long line, is of course using the shorthand for vbind, which is just the column. If we save this, you can see component, our project is still working. Now, the next step we can do is leaving out the props part here, because when we're using props in in our template, we can leave this out because Vue is smart enough to link this with just the name. So now we have this, and it's already a little bit shortened. Okay, the last step that we can do one more step, is one that we can do since Vue 3.4, is that we can remove this part, because when the prop name of child component is the same as the name of the value that you're passing into, Vue will link it up automatically for you. So we can leave this out, and now we only have this as the prop. Way shorter than hold with the vbind and everything. Save this still. Now that was my tip of shaving out a little part in the template tag of the single file component in Vue. Hope this is helpful, and enjoy Vue Nation.
All right, y'all, welcome back from break. Up first, before we introduce Maya, we are going to be talking about Vue School. Vue School now offers more than 130 hours of course content covering Vue.js and the broader ecosystem. With more content added each week, the library of courses is just growing and growing. Did you know that NASA studies Vue at Vue School? Apple developers too, and many more from other prominent organizations. During Vue Nation, Vue School's yearly plan is 50% off, giving you access to hundreds of hours of expert training for only $12.50 a month instead of the normal monthly plan of $25 per month. Whether you're just starting out or brushing up on advanced topics, there's something for everyone, including technologies like Tailwind, TypeScript, Pina, Nuxt, and many more. Head over to vueschool.io/sales/Vue.js Nation 25 to grab this deal while it lasts. And up next, we have Maya Chauvin. Maya will be talking to us about scaling state in Vue, why XState matters. Maya is a senior software engineer at Microsoft working exclusively with TypeScript and front-end frameworks. She is also an ambassador for Nuxt, a Google developer expert on web performance, and a media developer expert. Besides coding, Maya spends her spare time writing tutorials about JavaScript and best practices, speaks at conferences around the world. Maya is a very, very busy human, and thank you for joining us today. Welcome, Maya, to the stage. Yay, Maya.
Hey there. Oh, wow. I always have technical issue in the first time of my talk. So for some reason, it's the new computer. So yeah, you know how it goes. Hello there and welcome here. Today we're not going to talk about testing anymore. This time I'm going back to state management. Some fun with state management with XState. Shall we? Yep. So first and foremost, my name is Maya Shavin. I'm a senior software engineer at Microsoft. I've been working with the front end and full stack for many years, and I'm also the accessibility champion of Micro, which oversee accessibility compliance and make sure that everyone in my team are aware that accessibility is one of the important part when they designing on working with the UI. And currently a mother of four. Yeah, I just gone out maternity leave. I have a baby of 5 months, almost 6 months old, and I'm really tired all the time. And I'm a book author. And talking about book author, I just released a book on Learning View. And if you're interested in Learning View, learning how to work with TypeScript and Vue 3, check it out. And before we move forward, Happy Lunar New Year to whoever are celebrating Lunar New Year. And, and it's the year of the snake. So Happy New Year, con xin phá cái, chúc mừng năm mới. And we're ready to go. Yeah. So before we deep dive in XDay and why we're even here to talk about XDay, let's do a bit of recap of state management. We know that we always do state management, some sort of state management in our application development and everything. So why state management? Well, to avoid this. Oh, luckily this is only happening in Windows and not in my Mac. So yeah, well, it's annoying. I'm from Microsoft, so I cannot say anything about this. But it's a legend-proof screen, and we do state management to avoid this. No, not exactly. State management to know that we reach to this state and why we reach to this state, and we have a 20% complete there to tell you exactly how many percent you complete, why you crash. But actually, state management is doing more simpler things, like to answer more simpler scenario of questions. We need state management to answer one question in our application, which is how does the app react when something happens? When something happens mean when a user change something, interact with your applications, UI, so on and so forth. Anything happen in your application, or we can call it the way that the data flow. We keep the data flow consistent with state management. So either it's the input validations, or it's the warning, or even the form submission. That's the data flow, that's state management. And usually when we do things like input state management or simple app, we don't really need the whole complex system. We don't really need Vuex. We don't really need Linear for small application. We can easily build our own state management locally, or even a global state management for our app without complex solution. It's just small application. But once the application evolve, and once we have bigger and bigger application projects on in our pocket, there are more and more complex interactions, complex requirement, let's say complex user requirement and user expectation. And that make it into the fact that our system need to scale. And at some point, the management state manually, what we're doing right now, what we're building right now is not enough. And that's make us come to the fact that if we're not careful enough, we can end up into a situation we don't know how to debug, or we do know how to debug, we don't know what caused this problem. How many times any of you sitting there looking at the screen and say, where am I? What caused the UI not responding to me? It's supposed to work. It's supposed to work, right? But yeah, so that's come to state management, how we are supposed to do it correctly. Okay, this is one of the things. Yep. And before we dive in that complexity of state management, let's do a bit of recap of how we manage state in Vue at the moment. Thanks to the hard work of the Vue team and all the collaborators. We have a very good system for writing our state management efficiently, not just writing any state management, writing efficiently. So we have not React. Well, I got confused with that. I was supposed to React with a Vue here. So we have composition API with reactive, with rep, with computed, with watcher, and so on. And so let's say in this example, I just have a form multi-step wizard with two steps. I sign a form with name and email, and I keep track of the step. So every step I move, I will increase the step whenever I'm allowed to increase it. And what it does, it just move forward, get an email, submit it, and that's it. This is simple, right? You don't really need Pinia, you don't need Vue.js, you don't really need XD for this because it's just very simple. However, once you launch the product, then the product owner will come to you and say, hey, you know what? The user just come to me and say, I want to go back. And what happens if the user click next without filling any data? I'm supposed to get blocked from doing that. And then maybe when the user finish submission is submitted the form, he want to restart. How we going to restart the whole forms wizard without refreshing the whole page or the whole view? And what if the step is incremented outbound? Because like you say, we just increment by plus plus. What happened if we accidentally increment it by step 3 while we only have 2 steps? How are we going to display it? How are we going to plug it? And what happened after we click submit? Are we going to do something about management, the asynchronous submission status, like loading, arrow, and so on? Well, all of that have make into one thing, the state management problem for complexity. All of those kind of requirements add up into add up the complexity into your very minimal state management logic that you currently have. So let's look at our for view and multi-step form for the sign up form we just saw previously. So in this example, together with all the requirements, I came up with this store, or we call it the form store, that were written by Pinia. Well, again, this is Pinia, but it's written completely with also composition API. So you don't really need Pinia for anything unless you really take advantage of it, like really complex. Otherwise, you can actually use composition API to write your own something similar to Pinia, depending on how much time you have on hand. But anyway, so in this form store or data management, state management for our form, I actually keep 3 states: the step, the submission status, and the arrow. And then every time when I move next, I click on like I advance a step forward, and then I advance step backward if I move previous. And then of course I add in some guardian, like only move like decrease or increase if it's still without the bound. And then for submission, I also set the submission to loading to true, and set the arrow whenever it's needed, and reset the submitting status. And of course, need to advance the step to the last stage to indicate that this already finished to the last stage. And at this point, from all of this, you can see that I have a very, very complex, messy flow here. Look at this flow. The first thing you see, will you understand it? The second thing you will see, how I know where I am and where I'm supposed to go, or if I want to add something, how I'm supposed to know that I won't break anything. Because each of the step here, you check in, let's say step 4, if you add another step, you need to check here. You need to make sure that you advance the step, the number of steps, and you also make sure that you advance the last step instead of 4 to 5 and so on. And also on the data updating is scattered around. So the problem here is that it's not consistent anymore. It can be very inconsistent if it gets bigger and bigger and larger. And then all the asynchronous is much scattered. You kind of setting up the arrow everywhere. You don't have a way to do it. Like someone along the way will mess up. And even though the form, the handle, and asynchronous look similar to others process, you cannot reuse it, and it's very hard to debug. So now here comes the question: can we fix it? Yes, we can. can we define some sort of predefined state and the connection between them, and then let the system handle the state update, like the step update, like the status of the asynchronous update, and you can just focus on more important things like update the data, keeping track the data, and so on. Well, for that, we have state machine. Okay, so what is state machines? I would say state machines or finite state machine is just a code logic, or you can call it the model, or you can call it machine. What it does is that it defines a bunch of behavior of the system into finite number of state, which means a behavior of a system will be matched to a state. And the transition between one behavior to another behavior is called event. And we only use event to map the different state to each other, which means as you can imagine it's like a graph. So the state is actually the node of the graph, and the edge, which is the connection between one node to another node, is the transition event. And because you do one-to-one like that, we only can be in one state at a time. And there's no way that we have in two states, and there's no way that we don't know any state that we're not expected, because it's finite number of states. We need to know what is the number of states we have. One very common example for this is the traffic light, would have only three states: red, yellow, and green. And when you move from red, you move to yellow, and then from yellow to green, and from green to red, or vice versa, and so on. So in this case, if you want to add another state or add in additional logic, you know exactly where to add. Say if I add another color like blue, then I add it between red and yellow, and then I just adjust the edge, which is the event. Instead of going from red to yellow, I go from red to blue, and from blue to yellow. And then if something happened, I kind of pinpoint exactly where it will happen, that the potential bugs will happen. And for this, it's predictable, it's scalable, and it's debuggable. You know exactly where you are. You can narrow down where you can debug the problem that happened and find a fix for that. Okay, so that's about state machine. State for Vue, based on that, is the declarative predictable state logic framework that written in TypeScript, fully supported by TypeScript. It offers you a lot of different ways to write this, to do state management with guards, like from one state to another, how you can control the conditional transition and add in effect like context, data, extra data, telemetry, and so on. And of course, everything based on event. And for Vue, we can use XStage/Vue, which is the leverage the composition API. And when you plug in the machine with it, you already have this fully plugged into the Vue reactivity system. And the last thing that is awesome, I hope I will have time to show you, that you can actually visualize the state change using XStage State Machine with Stately team. They did a very good job in that. You can visualize the state and then get the generated code, and you don't have to write any code, very minimal. Anyway, so to install it, npm install XStage/Vue. And that comes to the thing. We're going to do a live demo, and what we're going to do in this live demo is we're going to refactor what we have in Pinia store for the sign-up form, the code that you see previously, into using state machine, and make sure that the state machine will handle all the transition automatically, and we only need to update the state and see how it goes. So some of the features we're going to handle here: we save the data to the context. We manage the switching between the state with back and next. We can retry. If the failed submission, we can restart the submission to a new submission. We can plus the submission without any data submitted, and we also handle error on submission. Okay, so let's see. So here is how it looks. You can see here, if I do text next, I will put it here, and it still can submit because I don't have any blocker here. And how do it look in the code? So if you go to the code, I have a form, which is the Pinia store. the code is what we just showed before. Nothing interesting here to see. The multiple form, I have the several input, and I have a lot of if, else, the step submitted. So now let's build a state machine. Okay. So in the multiple step state machine, I'm going to import from xstate. Yeah. I'm going to import a function called setup. This allow me to create a definition of multi-step machine config. Okay, the basic config for creating the setup. And then in this one, let's say I can do ID, and then I will set a multi-step. I can set up the initial step to be the first step is name. It's fine. But I also can set up it up once I create the state machine. Okay, so this config, the instance will have the function called create machine, and you can pass more customized state machine options into this to create your own instance of state machine. So in this one, I'm going to I'm not going to redefine the initial, so I'm going to define my state. Okay, so here I'm going to define my state, and I'm using ChatGPT, GitHub Copilot to help me with that. So I'm define the state. I define name, email, passports, and success. Okay, so here I don't want to set. I want to send transmit it to submit, which will not do anything yet. And then I will also add an arrow. Okay. And what also don't do anything yet. Okay. And what it does here, on the name, I will set an event connect, which target to email. Similarly, on email, I set the next to top password and the previous to name. And in password, I will not set this next. I will set the submit to submit. Okay. And the previous to email, and the submit, I'll leave it for now. Okay, so this is all I have for the state. I need to define a context to keep my own data for the form submission, which I will define the form data, and we'll have name, email, and password. Okay, great. Great. So now I have all of this already. I can go to the multiple form, and I will disable the store. I'm going to switch it to use the the multiple machine, okay, and do multi-step machine. Okay, just close it. Great. And then in here, I'm going to get exported. Okay, so I'm going to export this machine, and we're going to import it here. And now I'm going to create the instance. We're going to plug this machine inside the reactivity system of Vue application, and you use machine composable. And then I put this multi-step machine inside, and this one will return me an object that have several properties and methods. So one of them is the snapshot or the current state. So I can just map it to store to keep the convention, and I'll have some function for sending the event. Okay, so let's take a look. So here you can see the store tab equal for 1. For this one, I will do the store, and I will do the matches, and it will be named. So you don't compare directly the store, the current state. You use the matches function, and then I also do the same thing with all the with all the steps. So here I will do it email, okay, and out here I'll do it password. Okay, cool. So this is password, and of course the store format is not. So the store is actually inside the context. So I also fix the context. Okay, cool. And now I'm going to add one more thing. I need to update the data. So I'm going back to here, and I'm going to have another event that called update. It doesn't move, it just update, and I do actions. And then I'll and I do assign, which will assign the form data with the new data from the context and the event. Okay, great. And I will do the same for all of them. So I will add another one like this, but instead of name, I will add this email. And a password will also have this. Instead of email, I do a password. Okay, and then I'm going back here and I will do an input. And then a send, state type, a update, okay, and value. Okay, so I will just copy this and repeat it here. Let's just close this one so everyone can see my screen. Okay, great. So now I have already updated everything. Great. And now that's one thing. And now I need to handle the set previous and next. So here store previous or store next. So first of all, I need to handle the if here. So I wanted to make sure that I only display the back button if it's have previous, which I will do compute, and I'm not doing the store step here. I'm doing the store dot value matches. Okay, and I supposed to be have previous, and have previous doesn't have the name, so just make sure that it's the second stage or the third stage. And similarly, I have next. Okay, or email, and last, and that's pretty much it. And then I need to import this from Vue. Okay, great. And then here, I'm going back here, I'm going to the button. I'll just set here as previous, and also here as next. Next, okay, great. And now I have the submit form. And this submit form, I will also do the store, not match it, password, because that is the place where I can submit the form. Okay, so and then here I don't do that. I will do send, type, submit. Okay, and of course here also I will do send, and then type and previous, and this is also type equal next. Okay, let's try and hopefully it will work. Okay, so here is already here. I'll do next and I do next. Okay, so we can go back. Yeah. Let's see if it's showing here initial state. So I do need to put initial state here instead of in the setup. So I put initial state here, so it will not kill at me. Great. Now here comes the next thing. We need to disable the store when submitting. So how we do that? So I would check if the store can submit or not. Okay. And now how I'm going, not can submit. And how I'm going to check if the store can submit or not, I'm going to put some guard, which is the number of guards to guard my event transition. So in here I do the is for valid, and I do the context. Okay. And I'm going to be here that I get the name, email, password, and make sure nothing is empty. Okay, so I take the from valid. I'm going to the submit, and I'm going to change it. Instead of putting the text, I will just put in the target, submit, and put here the guard. And this should work. Now let's check. Hopefully. Okay. So here I'm going to leave the email empty, and you can see the submit button is empty, and I'm going to back here. The submit button is on. Okay, now it works. And now we need to handle sending, trigger the submission. So let's go to here. We have the submit button here. In XState, there's a nice thing about it that you don't really need to define the state or the actions and event. You can also invoke some sort of like some sort of additional actions, asynchronous actions. Let's say here I would invoke something called a mission, and on done, I would do target and success, and on arrow, I will move it to the different state called arrow. Okay, and the submit form, I will define it as one of the actor here. Okay, and the submit form will be it actually you need to get it promise from using from promise from XState to create a function to wrap around function. So it will map everything to it will map the asynchronous data handling like error, success state, result, recheck automatically into the state, into the event of your machine, so you don't have to manually update in it. So in here, I will put let's say in information something, and then I will just return fake API code. Okay, so fake API code is a function that's sending message to the server. Okay, so now I need to get some to pass some data here to be able to send to fake API code, right? So for that, I need to go back here and to the invoke, and here I can pass the input to the invoke function by put in the form data, or I can just spread it. Okay, and then in the submit form action here, I receive it as an input, and then I can just spread the input. And if you want to check, you can see if the form is submitting and get the input correctly. So let's try. So I say me, and then I'm going to email, and I'm going to do submit, and that you can see that I get the submit form, and also the form submitted successfully. And then I got the submit form data here. So let's take a look in the multiple form. If we go back here, and we can see that the else. This happened because there's a bug here that it just couldn't find the error, so it's formed successfully. But that's a bug. So for VLs, we would do the same thing. We will also do store, okay, match arrow, okay, and then instead of arrow, we can do like arrow submission, okay, and then we will do VL if. Also can do that, or maybe it's not needed because it automatically anyway. Great. And now if we finish with that. So now if we want to arrow, let's go to the fake API. And instead of doing that, we can do throw new arrow, not implemented. Okay. Yeah, and then let's try. Next, and submit. And you can see it's an arrow submission. And we don't need to do anything. We don't need to set arrow equal something. We don't need to keep track anything. We have the submission already. So let's just get it back. Okay. Okay, cool. And now I want to do one thing. If I submit successfully, it go to the successfully state, and I want to be able to reset and start a new section. So I do another one called reset. Okay, and then I don't disable anything, and that's one I'm going to be success and going to do start a new section. Okay, and that's mean in here. I'm going to the success. Okay, I'm going to define an event called reset, of course, and I'm going to target name, and of course I'm going to clear up the form. Let's see if it's work. So here I'm going to do Maya. I'm going to do add something. I don't really care. And I submit. Oh, wait. Submitting form, submission, did I save? Yep. So I probably do something wrong. Submission form, Maya, and okay, let's just try it again. And okay. So I probably doing something wrong. Let me see on arrow on target sets and go back here. Matches arrow and matches set. Anyway, you got my idea, and it should work. I probably did some small mistake right here, but I promise you it works before. Anyway, so that's it for our for the state machine. If you take a look at the form before and take a look at the multi-step, so each of the state is actually on the data is very common in here, very concise, and we don't have to keep all of this. We only need to keep the context, which is a form. That's it. And we can add in another step and so on and so forth. So what about the visualizer? The visualizer, let's say I'm going to Stately editor. That's a nice thing. If you go to the Stately file, and I'm going to go to Blank Canvas, here is the editor where you can actually create a new state. You can create by writing it, and then it will update the code here for you. Here. Or you can import it. So let me go here. I'm going to copy all of this, and I put it in here. And then I import this one. And then you can see, if you look inside here, you can see it gives you a visualization diagram of how your state flow look like. So from here, you can see that it's going to email on the next, and also it can go from the set, it go back to the name on reset. So when I do the simulate, I can do the simulate. I can do next button. It will move to email, and then we have 3 events to do, and then I can do next, and so on and so forth. You can also write here, or you can copy the code and paste back to your application. It's already good for ready to use, and that's pretty much it for our let's go back to our thing here. And that's mean from this state where we have no idea what we're doing, and actually it's very complex and very messy, we sorry. We come to a very nice written down, very organized, where you can see which state, which kind of event tied to the state, and what will be updated, and what we're supposed to understand, what we're supposed to expect from those state and actions. And of course, you can always debug, can always try to write here and show this to the product owner or to the designer to understand, the whole team to understand that this is your plan. It's very good in the design preview or design technical review meeting, where everyone will ask a lot of questions about how you design like this. And that's it. Before we finish, some key takeaway. So state machine make it very predictable, deterministic, because we know what it is, we can trace it, we can add additional telemetry, we know exactly how what we expected from one state to another. But that means we really need to predict it. We need to plan ahead how it looks. So it helps us to keep the state isolated. Like you saw, I have the machine. I can use the same machine in React code, in Vue code, in a different projects. And I just need to make a very minor change to match the UI, but overall, I can reuse it as much as I want. And it's really easy to perform the real-time debugging and testing. They have some inspector, and I haven't tried yet. Somehow it doesn't pop up anything. So you're supposed to have the inspector, like the Vue inspector and Nux inspector, that will show you how the state look like every time when you do the state change. And it's not for everything. The learning curve for step state is stiff. It's really not easy to grab from the first time. It's not straightforward. And you really need to wrap your head around the concept of plan your code, know what state you have, over than jump in the code and write whatever and make it work. So this is not for everything. Don't use it for something like toggle. Don't use it for something like like traffic lights, because it's not meant for that. It's too simple for it. But for things like step wizard, checkout card, authentication, complex step that handling combined between asynchronous data control and step, let's say, and local state handling, then XDay is definitely the case. I've been using XDay to create some sort of scheduler for my blog post, for my whole blog post workflow. So I can write a blog post, I can schedule it, and then I can schedule the content, generate the content for social media, and post it on social media to promote my post. This is the case for that. Other than that, you don't really need it. So evaluate, and of course, you should check out the resources for XDay, like the visualizer that we tried. It's really cool. Just to build some draft and to get people know how to use the how to see how you talk, or to just lay out your thought about how to design a system. And follow David K. Piano. He's the creator of XDay, and he's really cool, and he make a lot of nice stuff. So yep. And lastly, like I said, XDay is not for everyone, and also it's not for let's say make it work in the first time. Try to plan ahead your code and code later. Whenever you receive a feature, if it's big, try to plan ahead. If it's small, okay, don't mind me. And that's it. Thank you for joining my talk. I hope you enjoy my talk, and feel free to connect me on social media. Thank you.
Thank you, Maya. We do have some questions. All right. How do you handle async operations in XState?
Well, you know what? In XDay, async operation, you can handle it using the invoke, like the one I should show you in my demo. There's several ways to do it. Invoke is one of the things, and another thing, you can create some sort of transition state. So let's say the first state when you, for example, I have a state called fetch. And then I will do another state called loading. So I can, in fetch, I can send an event that go to loading, trigger something in advance, and then go to loading, which is the transition state. And the asynchronous actions finish, it will send another event to move from the transition state to another state. But that is pretty complex. So I like the invoke, where I like invoke better when I can handle it. But again, if you only handle asynchronous operation, I would suggest you to use Stack query instead, because it's built for that.
Thank you. All right. Can XState be used in TypeScript independent from Vue 2?
Yes, absolutely yes.
Sweet. Do you have any concrete use cases other than registration?
Well, I have a lot. Okay, if you want, I can show you. I mean, in my repository, we have I did a lot of I did a few example. One of the first talk about XDay I did for Vue Nation is also on how I build some sort of checkout machine. Like I built something like a corner wizard that you can actually reuse it in your code. So basically, you can just define the step yourself, like define the view for each of the step, and then you plug into my component, and it will automatically render into the step and map it into different state, like a machine for the wizard, and it know how to it how to move it with the step. And I call it Vurian Wizard, so you can find it in my repo. And a lot of other things like authentication is also a good example. Yeah.
Thank you. Two more. Could you explain how XState helps ensure validation and smooth transitions between different states of the form?
This one I need to get more elaboration because I'm not sure I understand the questions. So let's say you say validation is smooth transition. What do you mean exactly? For example, validation like input validations or just the whole form validation? Uh, so for example, let's say I have a name. So I update the name. I want to have some gore or some arrow on the name. That's probably, if that's what you meant, you can add another, you can add the nested state for validation, but you don't really need that. So talk to me. I really need to understand more about this question.
The next one starts with additionally. I don't know if they're linked. I don't think so. But yeah, it could be the follow-up. Additionally, what are the main benefits you've observed when using X state compared to other state management approaches for forms?
Oh, let's say if state is the very isolated and very well organized approach. So I personally like it because I can actually visualize and I can think, like I can really think ahead how many state I need for like it's really focused on data, the flow, like the state flow of interactions, not the data management like Pinia for like form, not like Vue validate for forms specifically to validate a certain input field. It's more like use it at the whole, to like use it at the high level to validate that you to keep to keep your state in one place and keep let's say more complex form for example, if you want to have the form that you do handles asynchronous together with the local state, and you want to save the data, but you don't want to be like the one that multiple step form that I just show you. So you want to save the data, but you don't want to keep track yourself of the status of the form, like which step we finish, which field you already complete, or something like that. So XState is great. And like you say, you can also take XState and put it in other code base, so you can create a whole design system like reusable machines for different projects if you find it in common. Other state approach, let's say for example, Vuex or Pinia are very Vue dedicated. And it can be that when you switch to different things, you need to you need to rewrite it. And other things, like it's complex, that you cannot really add trace where you are. Like trace, it's very hard for you to trace back if something happened, and because it's like a blind box over there. So
Awesome. Well, thank you so much, Maya. That was our last question. Thank you again for joining us today.
thank you.
All right, y'all. Before we go to our next speaker, we get to talk about Instant Dev. Our sponsor, Instant Dev, has reimagined development delivery for the modern tech world. They provide production-ready Vue code without the typical risks and delays. Start your project within 24 hours, scale your development as needed with their flexible credit system, and get quality guaranteed code every time. Whether you're building new features or launching a complete Vue application, Instant offers end-to-end delivery from a single expert team. And visit instantdev.io to see how they're making Vue.js development more predictable and efficient. And then up next, we are going to have Thorsten C-Shop, your own Vite plugin that's easy as 1, 2, 3D. Thorsten is a computer scientist and web engineer with expertise as a senior full stack software developer and web consultant. He combines technical skills with strategic insights to deliver innovative web solutions that drive success. Welcome to the stage, Thorsten.
Hello, everybody. I think I'm live. I hope you can hear me. I hope you can see everything here.
We can't see your screen. Oh, perfect. You brought it up then.
Just
Perfect. Thank
1
you.
second. No problem, no problem. You're absolutely
Perfect.
right. Okay, then I'm back here. Hi. So that's nice to see that the organizers are so behind everything and that they are checking everything. And it's a tough time schedule today. I saw that my time slot jumped around 20 minutes for and after. But I hope we are set. So let's relax a little bit together for the next 20 minutes or so. It's last talk of the day, and then you can all go grab something to eat and enjoy your evening. So my name is Thorsten. Thanks for the warm welcome. I'm a computer scientist and web engineer with a master degrees, currently working at a full stack developer. And the title, your own Vite plugin, that's as easy as 1, 2, 3D, suggests a little bit what I'm going to talk about in the next minutes. You can find me, of course, on various social media, but let's debrief a little bit. Maybe we want to make a plugin. We want to make something with 3D, GLTF files or stuff like that. And it would be very cool if it's not only for Vite, but maybe we can build something builder tool agnostic so that we can run it in other environments as well. So in the talk, we briefly talk about GLTF files. What are GLTF files? What we can use them for. Of course, you want to make them type safe in the end in order to make cool stuff with it. Then we want to build a Vite plugin on top of it with pre-processing. We want to generate some code that we can then use in our Vue project at the end. And like already said, it would be very cool if it's a plugin not only for Vue, but also for maybe other frameworks that are out, for example, Next or all the others that there are. And in order to do that, we want to bring the Vite and the Vue away and bring unplugin in play. And unplugin is something really cool I want to talk about in just a few seconds that helps plugins more or less create build tool agnostic plugins that then run in. Of course, it will deliver something for Vite so that you can use it in Vue and Next, or all the other bundle tools like ESBuild, Rollup, and what also they are called. So GLTF files, what are they? In 2015, just a little bit of historical recap, there was the first version of GLTF 1.0. It introduced a file format that we can deliver on the web to have 3D assets and whole scenes, cameras, lighting, and stuff like that. And in 2017, there was a second version of it, GLTF 2.0, that is used until today in 3 kind of exports. We can export GLTF separated files so that we have a GLTF file that is a JSON encoded meta file that holds together all the things that are happening in the scene, the camera, the nodes, and stuff like that. Then there can be binary encoded files with it that have, for example, the models and some textures like PNG image files in general. We can also use GLTF embedded. With this, you have only one GLTF file that is still JSON encoded, but all the other assets, the bin files, the textures, and so on, are base 64 encoded inside the URI as a data field. So the GTF files get rather big, but you have everything in one single file. Also, in one single file, you could use the GLTF binary. Here you have a binary GLB file that is, of course, more or less optimized, but in it, the files are bundled. To be precise, there is still some JSON meta information in it and some also textures, and also you can have some bins that are all in one binary encoded file in the end. Okay, but let's look in one GLTF file to get a little bit a glimpse of how it works. So on the left side, you have a GLTF example, and on the right side, you have the object hierarchy. Here, this is something like the scene graph at runtime, but it represents how the objects are linked to each other. For example, at the top, we have the scenes, and it can have one scene, it can have multiple scenes. That is completely up to you. It's an array. And inside the scenes, you have some nodes. You can see them here. The nodes are the indices of the array of the nodes part. So here you can see the nodes, also an array. You can have many, many nodes. And on position 0, there is, of course, a node, and in the index 1, there is a node, index 2, there's a node, and so on, and they are linked. The same like the meshes are linked. So here we have a mesh number 4. So we have then look in the mesh array on the bottom, and on position, because it's an array number 4, there is the mesh that is linked to the node in our object graph. And this continues until the bottom. And on the bottom, you have some additional files like talked before. We have the buffers and the images. These are the URIs I talked about. In this example, I am linking external files. But like already said, you can also base 64 encode the things inside the GLTF file. Okay, how is this rendered? In the end, you have the GPU at the bottom of your computer. On top of the GPU, you then have WebGL. We all know WebGL. It's the thing that brings 3D in our browser. It's a very low-level API. It has direct GPU integration and is rather complex. So to abstract it a little bit, we use Vue.js. I think everyone here has already heard of Vue.js. It's a more high-level framework for WebGL. It helps you easier talk with the graphics card by abstracting WebGL commands. And on top of Vue.js, there are several libraries out there. In, for example, our case, for Vue and Next, there's Stress.js. A shout out to Alvaro and his team at this point for this awesome library, but also in other frameworks, there are other things. For example, you can use Drei in React or Threlte in Svelte, and so on and so on. Okay, let's see how we can load a GLTF file in for Vue.js and also in Stress.js for our case. On the left side, you see how you can load a GLTF file in Vue, and on the right side, you have the abstraction, the helper possibilities from Tress. In this case, we must use CentOS in order to use GLTF files. It's an extension for Stress.js. And you see already some differences. On the right side, you have the Vue syntax we all know and we all love. And on the left side, we have pure JavaScript. But in the end, Tress is built on top of Vue.js, so it wraps and helps us using it. You see here, I am loading our island GLTF file on the left side and also our island GLTF file on the right side. And both get the scene object here. It's the first entry point in our scene graph. And from there on, we can go on, you can see it here, all the nodes from the scene graph before, so like the cameras, the assets, and so on and so on and so on. Okay, but loading it this way has some problems. It loads only at runtime. That's the first thing you're encountering. So no help in dev at all. You have no typings, no code completions. You can do not call maybe island.beach.rock1 or something like that. You have no safeguards. If you're mistyping your names or maybe your files are missing at bundle time, you get no errors at all. The thing compiles, and only in the browser, the end user has some errors that you cannot catch at all at build or dev time. Also, there is a way you can get objects by name, like with this get object by name property on a node. But with this, you have a depth-first approach to find it in the scene graph. And worst case, you have to go through and walk through the whole graph in order to only find the last node that is the rock you want. So a very bad runtime when you get with this your nodes. Also, all your assets are always compiled. They are always public. So if you only use one of 5 models, all 5 models go into your build folder in the end. So how can we ensure making this a little bit better? With the type generation I talked about earlier. So we had developing the plugin, I want to show you at the end some problems on the go. So at first, Vue.js is only, like already said, a runtime environment. You can use it in the browser. There are some extensions to it, like the Draco compression. I don't want to go too deep in it, but you can make really cool things with it, but all only in the browser. So our solution was we patch Vue.js. It's as easy as that. If you want to build something that your beloved framework or operating system is not giving you, just change it. This brings a little bit of complexity and another problem with it. Patching Vue.js in order to run it in the Node environment would mean that we need two versions of Vue. The one version of Vue.js we are using in node time to generate types, and a second version of Vue.js that the user in the end in his application or his or her application can use for really loading to runtime the models after building the project. And these are the patch plugin from our side for the node and the original for the user. The solution for this is that we are using the Vue stdlib. It's more or less just a clone of the Vue.js example directory with an own Vue.js runtime, a fully runtime bundled in it. So we can patch this and don't have to worry about what the user is making with his own Vue.js library. Okay, also something we had to consider on our way for this plugin was an API design we had to decide on. So what route do we want to go for the user end app? We could, for example, go the way, say that usability is the most important thing to us. For example, by prioritizing the usability, we could make something very easy like, okay, let's say you are loading the scene, right? And then you have the island scene. Just make a dot and you get auto-completion for all nodes that are in the root of island scene. In our example, island. After you have typed island, you can set a dot and get all the nodes that are in island. So here, beach. And on the beach, there are rock. 1, 2, 3, 4. Very easy, very straightforward, something we all know, we all are using on a daily basis, but it has some downsides. The first downside and the biggest downside is that we have to create this potentially very large object of the scene, the complete scene graph, in one single object and ship it. But the positive side, the user can really easy work with it. So a second approach would be we want to prioritize the bundle size. Because this object is quite large, we maybe want to only ship the things the user really is using. And this could be achieved by creating getter functions. And each getter function must be provided by the parent. So you get the thing from the other side. So we are not starting with the scene graph on its root. We are starting at the leaves. And the leaf is the rock. So we want to get the rock. And in order to get the rock, we must pass the parent. The parent is the beach, and so on. Of course, this is not very user-friendly, but we could potentially tree shake it. And then we have a good bundle size in the end. Or a third approach would be to combine it. We could crawl the user code. We could analyze the code and the project the user is creating, but don't get me started on this one. So the implementation was after deciding on the usability part. So we want to make something that the user can easily use. And we do not care about the bundle size too much because in the end, making the whole object is in comparison to the object itself and the bin files, even if they are Draco compressed, a very small proportion. So we are just taking this user approach and the bundle size is not to matter too much. We run Vue.js in our node environment and pipe the models into it. That's the first step we are doing in order to get the runtime objects. So we are not passing the GLTF files our own. We are letting Vue handle it. So we really get what Vue would also generate at runtime later in the browser. So it's very easy. We can work with that. And if the Vue.js has a breaking change or something like that, we also adapt to this on top because we do not have a second reality. We must ship also with new versions. After we have created this runtime object, we generate the types with it. And by that, we're taking the names of the children. and linking them with the indices of the children inside the arrays. And then we use handlebars to generate the files we then want to use in the project. And here in the example, we had GLTF separated. So the first 4 black shown files are what the user has provided in the project, and only the second last files are what we are generating. We're generating the types, and we are generating the real code, the helper functions that the user can use in the project. How does this look like, you may ask? Let me show you by an example. I have the island example from before. On the left side, you can see the types file, and on the right side, you see the generated code that the user can then import and use. And you can see a little bit about the magic. The big object is here. Of course, in this example, we have a very small object, but trust me, this can get very fast, very large, thousands of lines, only to get the scene quite right. And we store only the indices of the children, like I said, in the arrays. So here you have 0, 0, 0, 0. Of course, it's an easy example because always it's a position 1 in the array. But later with real scenes, there are all kinds of numbers depending on the index of the array that is shown. And the typing is done down here with the get node. And you see we are getting groups with the first, the second, and the third function. And the last one is returning a mesh. So we are crawling the real type inside the generated object from Vue.js and pasting it in here so that when you are using the GLTF file type safe in your code, you get the real type that the Vue.js is rendering out of the GLTF file. Okay, so we had some problems I showed you before. Now let's talk about the solutions we are providing with our approach. The first thing was that it only loads at runtime. Okay, we fixed that. We now have a patched Vue.js version. We can trigger in dev and in build time and have full control over it. So we have typings, we have code completion, we have safeguards on build, we get notified if a model is missing, or if someone in, for example, Blender changed the names of the nodes and we are not able to get maybe rock 001 because it's now stone 001. We get a type error and we get this on compile time. Also, we can make some calls inside the scene graph, and it's only going the direct way we want to go. No searching, no depth first, no other algorithms you could throw on it. All easy as that. Also, the models are now in the source assets folder, so we can version them, and only the models we are using get in the bundle directory at the end. So that's cool. That's awesome. Now we have a Vite plugin for Vue. Now let's make it bundle tool agnostic, or build tool agnostic to be precise. And we are using for this Vue.js unplugin. It's a unified plugin system for build tools. And like Alex would say, big shout out on this point, it's like jQuery for build tools. He said it yesterday to me and I was fascinated about this. So yeah, it's in the end, it is exactly that. You can build one plugin and then ship it to all kinds of build tools out there for Vite, for Rollup, Webpack, and what you want. You name it, and it is there. Of course, it is not 100% out of the box possible to do it because the bundles are different to each other. Not everything we have in Vite, we also have in Webpack or in AS build. And that is where our challenges began implementing this. The first thing we noticed was that the documentation is not always correct on Vue.js. I know we can contribute to it, and we all should contribute to open source software because it's very important. But just to have one example is this one, so that the, for example, load include is okay for everything except for the farm bundler. We don't know why, but it's a little bit of a mismatch. Something must be patched there. This is one of the challenges. You have to get behind of it because, of course, in the first iteration, you always trust the documentation. The next thing is that ES build does not allow us watching the files, or only allowing us watching files in separate build phases, not always. And this limits the watcher benefits because, of course, you want to have a watcher. If you change your GLTF files, load new ones in, load some out. And this is not easy with the ES build. And this was also a limitation we came across. Also, the emit files does not work with every bundler the same, because some does not return your generated file name after putting it in the assets. So so the solution is that, yeah, they are built different. And our solution to it is that we just make a fixed file name for it and provide the file name. We hashed our own, and we do not want that the bundler is hashing the file name itself. Of course, these are only 3 examples. There were other challenges as well, but it's like all software projects. There are difficulties you have to find, and you have to get over it. And also we had with the Yarn plugin. Okay, also just the last one, you have some problems finding if you are in dev or in build. That is very frustrating. It's not always in all possible. So sometimes you do not know if you're in build or in dev. Yeah, we have to work some way around it. It's a very hacky, it's not perfect at the moment, but we're working on it. And we want to contribute our solution in the end that others have not the same struggles that we had. So all of this made our awesome new plugin. We also published it this day. At this point, a very, very big thanks to Andreas Fehm, one of my best mates. He programmed yesterday until late in the night to change the last, to fix the last bugs and made some new improvements to it. And I saw like 20 minutes ago, he already encountered some of the open issues we had opened this morning. But yeah, that is our plugin. You can go on it on GitHub. You can give it a star. You can try it out yourself. It is well documented. We hope so. You can contribute to it and play with it a little bit. And on the bottom, you also see which problems we have with the bundlers, like I told, because not everything is perfect yet. So how do you use, or why do you need it in the end? Of course, to all the nice things I talked already, the code completion, the build failure, the type safetiness, and in order to not lose your head in complex scenes. So for example, we are building a little demo, a proof of concept for a little in-game browser game that is fully, I'm sorry for that, that is fully, could I please? Okay. That is fully working in the browser without installations or stuff like that. And it is built with Vue.js and Tress. And also here, a big shout out to Andreas for helping and for doing this with me. I'm just building a little windmill here while we are waiting. And I'm talking about the complexity of this scene. Also, this little island has so many nodes that we had problems just by, okay, which tree is where? Okay, we need a second tree. We must rename the first tree. We must refactor it. And it is breaking every day in the end. So that's why we decided to make this plugin in order to also help our own lives. And also something like, yeah, okay, I have a windmill now. The wind turbine should rotate. Okay, it should not rotate this fast. But getting the wind turbine is something like, yeah, windmill.wind turbine. Perfect. I have the node. It's perfectly typed. I can then dot rotate x equals something on delta, and that's it. It's very, very easy and very cool to use. So the takeaway for this talk is in the end exactly the slide I showed at the beginning. We made a cool plugin. We used Unplugin to ship it to all kinds of build tools. And then now we can use it in all kind of project. We are using it in Vue because the little island game is made in Vue, but Next is also supported. Also, you can use it in Astro. Whatever you want, you call it, there it is. So thanks for listening to me. Here are all the neat links to the source codes and the licenses and all the stuff like that. Check it out, go there, give it a star, play with the game a little bit, contribute to the game. And just one last thing, because tomorrow Alvarez is giving a talk about post-processing, and I'm very hyped about this, we also have something here to highlight the build plates. And this is done with the old post-processing. So I hope we all are learning tomorrow something cool. And we can then fix the problem that in the night, the post-processing is gone. Thanks for your attention.
Splendid. Thank you. We do have a couple questions. To start with, how do you handle error reporting in Vite plugins?
It depends on the kind of errors. So so the errors that are from the Vite environment are thrown from Vite itself. We are not piping them, we are not touching them. The only errors we must raise ourselves is in our core, and the core is about the GLTF, type generation and all like this. And there is an unplugin hook where what you can use then to raise errors, and it is raised in whatever build tool there is at the end, and it raises Vite errors, of course, when you're in a Vite environment, but direct Vite errors we do not touch.
Awesome. Thank you. All right. Oops, I made it go away. What strategies do you use for testing Vite plugins? I feel like you kind of answered that with the first one, but could you go into more detail?
Yeah, I can try. So of course, we all should write tests, and we try to deliver the tests in the next days. But at the moment, we do not have any tests at all. It was a very short notice for ourselves to get this plugin up and running, to get it tested locally in the end in order to use it. But there are no tests, so very sorry, these are only coming.
All right. And how do you handle development versus production modes in plugins?
Yeah, that is something I talked about. It is not, there is no hook or no variable you can call in order to get, I'm in dev, I'm in build, I'm in production or something like that. So you can check out the code, of course. We made some workarounds by just checking if some variables are present, because some bundlers like ES build are putting special variables only in the dev mode. They are changing inside the dev mode, but they are there in the dev mode. So we can check on the existence, and then we know, okay, we might be in the dev, but maybe they change it in the future. So there should be something more reliable, but for the moment it is working. We tested it, so trust us, I think. But the code is open source, so check it out.
Awesome. Thank you again. And yeah, go check out it's there. Perfect.
Yes.
You can see it quickly on the screen, and people definitely reach out. It looks like people have linked it in the chat as well. So thank you for joining us today, Thorsten.
Thanks for having me. Bye.
All right. We have our last speaker of the day. Laurent Cazenove, how dependency injection rescued my app from the untestable abyss. Laurent is a developer advocate, leveraging his extensive experience in developer relations, public speaking, and programming. He is passionate about bringing the gap between technology and its users. Welcome to the stage, Laurent.
All right. Hello, everyone. So today I want to talk about how dependency injection saved my untestable app. First, a little bit about me. I'm Laurent. I'm a developer experience engineer at Melisearch. You can find me on social media, usually at Strift or Strift Codes on Twitter, or laurentcazeneuve.com on Blue Sky. laurentcazeneuve.com also happened to be my blog, so you can find my writing there. All right, today I want to talk about how to build testable apps with dependency injection. So here's a little bit of story beforehand. This happened to me because I had a legacy app running over Firebase, and I wanted to try and migrate to Supabase. I had good integrations test using Firebase and Militars in local, but my business logic was just like too tightly coupled with the Firebase code. So basically what started as a keep it simple approach ended up having like leaking implementation details, super bloated composable, and untestable code in general because of the mess of business and dependency logic. It was really hard to know where to start for this migration, and what felt particularly bad was that there was no way for me to leverage my test to help in that migration. Fortunately, I found a solution, and that's what I want to talk about today. I want to talk about how we can build testable apps using dependency injection. So I hope you walk away with the following learnings, which is how we can clean up our composables, how we can decouple the business logic from the dependencies, and how we can write more testable code. All right, so we'll do this using a simple example of a user list component. So our component use a get users function that it receives from the use users composable, and it uses it in a async data hook to do the data fetching. And then we simply display the data. That's it. So if we look at the use user composable code, it uses the Supabase client. So yeah, here I have the opposite example. I'm using Supabase from the get-go, but it's the same. And then the get user function is just actually using Supabase to retrieve the users from the database, and then we return that function so that components can use it from the composable. Fairly simple composable as well. How can we test this is the question. So testing our component with Nuxt, here's the anatomy of a test. So first we have the imports, obviously. Then we have the test case. So this is the user list component, and we have a single test. We test that it renders a user list. Then we mount the suspended component. A mount suspended is a helper from Nuxt utils that allows us to resolve the top level awaits in our components so that we can actually test the data fetching logic. And then we have the assertion. I want to check that there are 3 users, Harry, Ron, and Hermione, on my page. So this is good, but what if I don't want to use Supabase in my test? Say I want to use an in-memory database to speed up testing in local. So I guess the naive approach would be simply mocking the use users composable so that it returns the list of users. That would speed up the test, right? Sounds pretty good. That's you're clicking, for example, in the data stream, like anything that would come in and would affect your component in a similar way as prop would do, basically. And the outputs, output is DOM elements, so what's rendered, the emitted events, like if someone clicks, I don't know, on a button to close a model, you want to check that this event is emitted, and the side effects like logging to the console, for example. The rest is implementation details. So in the case of our use users composable, it is an internal implementation detail of our component. We don't want the test to break if that implementation detail change. Say, instead of calling the function get users, I want to call it fetch users. I don't want my test to break for this. So if you want to look at it from another angle, consider that we want to make the test readability better. Our concern here is actually the database dependency, not the behavior of the component. We just want to use an in-memory database instead of Supabase to speed up the tests. So I think the code should convey this. We should make it clear to the reader that the business logic is not the concern here. It's simply the dependency. So knowing that, how can we write a better test? So another attempt would be to mock the database, right? So instead of mocking the user function, we would mock the use Supabase client function. And we will make it return the data we want Harry, Ron, and Hermione, right? So this is simple enough for a basic use case, but you can see that it can easily get very complicated if we had multiple database calls, right? What if we wanted different columns in our user table, or if we wanted to query a different table? We can see that this is not scalable because our mock would pretty much require advanced factory implementation to be able to handle all the use cases, or we would pretty much have to rewrite the mock implementation for each test. But it works. Still, is this really what we want to do? Because now our test is actually very tightly coupled with our Supabase implementation, which feels really out of place. The goal here is not to check that we implemented Supabase properly. It's actually all the opposite. We just wanted to remove Supabase from the picture altogether. This is very complex to test because I think our code is actually very integrated with the Supabase dependency. And this should also raise warning about another anti-pattern of testing, which is we should not mock what we don't own. And here we don't own Supabase dependency. So there's probably another way to do it better. They say that we can solve any problem in software engineering by introducing an extra level of indirection. If we talk about this with more simple terms, it basically means that we can solve any problem of complexity like the one we have by introducing a new level of abstraction. Okay, concretely, this means we should wrap our dependency. We should wrap the stuff we don't own so that we can create a API that we have control over. And let's see how we can do this. So in our case, we can create a use database composable that will wrap the use Supabase client. So this code does two things. We pull the Supabase client, and then we implement a method, which is called findAll, and that wraps the Supabase implementation detail. And by doing so, we abstracted away the implementation detail of interacting with database. Now, our users function, or composable rather, is much simpler. We just have to pull the database, and we use it to find all users. The benefits is that now the code is focused on business logic. So this makes reading it much easier, but it will also make migration easier and make testing easier. Let's see what this changes our test. So now we can just mock the use database composable, which is our wrapper of the dependency, instead of mocking the Supabase client, which is conceptually better, right? It's more explicit for code readers. We're mocking the interface with the dependency, not the way the dependency itself works. And we're not mocking use user either, which is the internal behavior of our component. At least now, if I don't want to use Supabase, I can only mock this composable, right? Yay! But we still can't swap databases. There's no easy way for us to use another real database for test, say an in-memory database, like I said, to speed up the testing. And we can only mock, not actually replace the dependency. So our use database composable is still tightly coupled with Supabase. We just move the relationship between the application code and the dependency one level higher. And what if we want to change databases? Like in my scenario, say I want to migrate from Supabase to Firebase, which was the opposite of what happened to me in real life. Or I want to migrate, like I said, to an in-memory database to speed up the test. Can we leverage our test for this? Imagine I want to do some TDD and just like replace Supabase with Firebase in my code and write some optimistic code and then try and use the test to fix the implementation. What would happen? Nightmare. We'd change the code, but all the tests will still work because all connections to the database are mocked. This might be what we want if you had dedicated integration tests for the Supabase implementation, but it's not our scenario here. But what feels worse is that there is no way to run the test and like simply say, use Firebase instead of Supabase. And despite having written all these tests, there's no way to leverage them to help in our migration. So this just felt wrong, right? Let's zoom in a bit, zoom out rather, and look at it from like a software design point of view. What we're dealing with here is a case of tight coupling between our composable, the use database, composable, and its dependency, which is Supabase in that case. It might not look like it because Nuxt module actually creates the instance for us, and we just call the use Supabase client composable to retrieve it. But in reality, there's a strong relationship between these two parts of the code. Use database is actually responsible for choosing the dependency to use. Let's look at what would be the alternative to clarify what I'm saying. So what are the alternatives? So first we have the scenario which we are currently in, which is the function is responsible for its dependency. Let's look at the example of this function. The getUserById function here is actually responsible for creating the database. And then it uses the database to retrieve a user. The opposite would be the function dependency being injected. So in this example, we can see that getUserById receive the database by function parameters, and then it can simply use it instead of having to know how to build it. So the second scenario is actually a well-known design pattern called dependency injection. Dependency injection, often shortened DI, is a design pattern where objects or modules, part of the codes, do not create their own dependencies. Instead, the dependencies are injected from the outside, like we saw with function parameters, or it can be the case with like a constructor for a class. Basically, let's see how we can apply this to our use database example. We have this composable, right, that allows us to interact with the database, but we don't want it to be responsible for actually creating the connection with the database, right? We want it to receive this dependency by injection, so it would not have to care about which database it's using or how is the database created. It would basically simply rely on an interface, a contract of, okay, this is how the database works. This is the available methods I can work with. And the function would just have to say, okay, I use the database, I query a table, and I return the data. That's it. How can we implement this? With Nuxt. So with Nuxt, today I want to show you how to do it using plugins. So we could use a Nuxt plugin to provide the dependency, and then the other part of the code we'll be able to use inject, or in the case of Nuxt, pull it from the Nuxt app to retrieve the dependency and use it anywhere. By doing so, we would actually be using the Nuxt app as our IOC container. In the context of dependency injection, IOC stands for inversion of control. The inversion of control containers centralizes the responsibility of creating and managing the dependencies, if you have many. And this centralization is actually what makes it easier to swap the implementations. For example, for test, to use the in-memory database, or in the case of a migration, to move over Firebase. By the way, this works very similarly if you're using vanilla Vue. You would just be using app-level provide instead of Nuxt provide. All right, let's see how we can do this with the Nuxt plugin. So we define our plugin. In our plugin, we instantiate our Supabase service, and we provide it to the app. We can see here that we are importing a type database. This is the interface that the app works with. It doesn't care that it's actually Supabase. It just knows it's a database. And now our use database function becomes a simple wrapper around the injected service. And we are able to move the code responsible for implementing Supabase to a dedicated file, right? So this interface will implement, this class rather, will implement our database interface, and will implement the find all method that is actually using Supabase. But now that's contained in here. We have a dedicated class for this implementation, and it's not leaking in the use database function. And this opens up new possibilities, right? Because now we can have multiple implementation of the database interface, and we could say, check for runtime configuration to instantiate different class and have different dependencies per different environment. So if you want to update our plugin to do that, instead of simply instantiating the Supabase plugin, we could first check for the runtime configuration, instantiate a different database implementation based on that config. All right, let's zoom out again and see what we really gained by doing so. The first benefit, obviously, is the separation of concerns. What do I mean by that? Now our code pulls its dependencies from the IOC container. So our business logic is completely free of dependency concern. This means our use database composable is not responsible anymore for retrieving the database or knowing how to instantiate it or configure it. It is injected from the outside. Let's see what this unlocks in our tests. We can now swap dependency at the test level. This example uses Vue, so I have to wrap my component in a suspense so that we can resolve top-level await. But we can see here that when we mount the component, we can inject a database at the Vue instance level. And we're not mocking any internal behavior here, and we're providing a real database, not a mock. So in the case of a Firebase migration example, this would help us verify that our implementation of the Firebase database work. We can still use mock, by the way, if we need it for specific example, but now we have more possibilities. Let's see the same thing with Nuxt. We can also swap the dependency at the test level when using Nuxt. But because we're using Nuxt, we're actually still relying on the mock here because, as we saw earlier, our implementation relies on Nuxt application providing the dependency. So it needs to run in the Nuxt app, and it needs to have the Nuxt app available. So I am mocking the use database function so that it returns a different implementation of the database. But we're not mocking the database here. We're just mocking the wrapper around inject. We're passing it a real implementation, so it can still help us in our migration scenario. And we're still not mocking any internals of our component's behavior. So this is how we can do it at the test level. But thanks to our new implementation, We can even do it at a higher level. We can actually swap the dependency per environment using the runtime configuration option we introduced earlier. So here, I'm just updating the runtime configuration via vtest. So when I run my test, I want the database driver to be memory. And then my plugin will use that value to instantiate a different driver, and all my tests will run with a different dependency. So in our example, I could have the memory driver to run tests with in-memory database in local. I could run the test with the Firebase implementation, say in a staging environment, and I could still have my app running with the Supabase database implementation in production. All right, let's recap what we learned here. So I think the main benefits of dependency injection in our Vue or Next app here is that we managed to decouple the business logic, so fetching users from the dependency, which is connecting to Supabase user table and making a select request. We also managed to centralize the dependency creation and configuration in the Next plugin. And this actually enabled us to write more robust and explicit tests, because now there's a single place to manage dependency, a single place to override it. And this in turn resulted in facilitating the implementation changes. Basically, to summarize, dependency injection allows for a more flexible architecture, and this enables easier evolutions and more leverage for your tests. Before I let you continue enjoy this conference, some closing thoughts. A couple of things to keep in mind, basically. Both in Next and in Vue, the plugin codes we have run on every page. So if you are going to implement dependency injection the same way I did, you need to make sure you lazy load your imports to avoid bundling too much dependencies in your bundle entry point. Furthermore, you need to make sure you're not providing unnecessary services dependencies in your bundle, because it will run on every page, like I said. And yeah, I think that is it. Thank you for your attention. If you have any question regarding the talk, feel free to find me online or on social medias. And until then, enjoy the conference. Cheers.
Yay, thank you for joining us. All right, y'all, we have done it. Thank you for hanging out with us today. Be sure to explore the expo area and snag those exclusive offers. Big shout out to our amazing speakers. Your knowledge and expertise help these events to come true. Thanks for all of your contributions. And huge shout out to our sponsors. Thank you. Team Tito, Instant Dev, Certificates Dev, Vue School, Weekly Vue News, Game Dev JS, Vue Designer, This is Learning, and Vue.js Berlin. And thank you to all of the community partners who have supported this event. Without you, these events would not be possible. Support our sponsors so we can create more amazing events. And also, Bitter Brains has more things coming up in June, like go check out Front End Nation. We will be hosting an event in June by Bitter Brains, so definitely go check this out. And if you haven't yet, make sure that you subscribe to Vue School YouTube channel. Vue School will upload all the videos from the conference to YouTube channel. The videos will be available in a few weeks after the conference. On the YouTube channel, you can also find previous events Vue School has organized and the talks of all the amazing Vue.js community. Subscribe to be updated on new releases. And of course, make sure that you're doing the survey, because that survey, you have a chance to win, but also we need your thoughts so we can make this even better. And giveaway winners for the scavenger hunt, Enrique Francois, congratulations. We will be reaching out to you via email. And Griffin, you won. I love this. This is like, I can now like it and repost it because I was waiting. I really wanted to like and repost. You won the Dev Stack Challenge. So thank you for joining us and posting yours. So y'all make sure that you do it tomorrow so we can announce our next winner. And we will see you tomorrow for day 2. Bye.
Are you ready?
Hey folks, this is just a sneak peek into the treasure trove at viewschool.io, your go-to for over 70 top-notch courses on Vue.js, Nuxt, TypeScript, and more, all developed by industry experts. From Pinia and Vue Router to upcoming features in Nuxt 4, we have got you covered. Start with the basics or dive into advanced topics like performance hacks, AI with GPT-4, and even web scraping. For Vue.js Nation only, grab 50% off yearly or lifetime plans. Head to viewschool.io/plans today, don't wait.
Hey everyone, it's Michael Thiessen here, and I am your instructor for Mastering Nuxt 3. And Mastering Nuxt 3 is a really awesome course if you are looking to learn Nuxt 3. We start from the very beginning with understanding how routing works, how you can put together dynamic routes with children, nested, and we go from there all the way down to the back end. We cover a whole wide array of things that will help you to build real-world full-stack applications with Nuxt 3.
Hi everyone, my name is Eduardo. I'm a front-end freelancer and a Vue.js core team member since 2017 or such, and I'm known for being the author of Vue Router and also Pinia. You will gain a comprehensive understanding of state management with Vue.js in many scenarios, including Nuxt with server-side rendering. We also explore concepts that are available in both Vue and Nuxt, such as refactoring with composables and unit testing. I created Mastering Pinia based on how I designed Pinia and how I have seen it used in real-world applications by companies I have consulted for. I believe in the power of hands-on learning, so I've designed this course to prioritize practice over passive viewing. In it, we dive deep into Pinia, covering everything from the basics to the most advanced features like plugins and server-side rendering.